Okay, today we're going to continue talking about balanced and unbalanced forces. On our first slide, it says you go bowling and you send a ball down the lane. It goes and goes on and on until it hits the pins and comes to a stop. What would have happened if the pins weren't there at the end of the lane? Newton's first law says an object at rest stays at rest, and an object in motion stays in motion with the same speed in the same direction unless acted upon by an unbalanced force. What is force? A force is a push or a pull that causes an object to stop, move, or change direction. What is the unbalanced force? To find the answer, think about a textbook on a table. There are two forces acting on the book. One force is the Earth's gravitational pull. Gravity is a pull that exerts a downward force. The other force is a push of the table on the book, which pushes it up on the book. These two forces are equal magnitude and act in opposite directions, so they balance each other out. A balanced force is when two forces equal in size and acting in opposite directions of each other. The object does not move, or the object continues to move at a constant, same, not accelerating or decelerating speed in the same direction. An example would be driving a car at a constant speed over 40 miles per hour in the same direction. An unbalanced force occurs when there are two forces that are not equal in size and act in opposite directions. Unbalanced forces cause a change of motion in position, direction, or speed. An example of unbalanced force would be a soccer ball after you've kicked it. A resting position in when the object remains in the same spot relative to another object. The direction of an object is the straight path an object can move along. Speed of an object is the rate of change of the position or distance traveled in a period of time. You go bowling, you send Okay, so based on what I just read, you're going to answer these questions. Which could be an example of a balanced force? A trophy on a shelf in a trophy case. B, a car accelerating from a stop sign. C, a box of dishes falling from a counter. D, a rocket taking off. Take and circle your answer. True or false? A balanced force only occurs on an object that is not moving. Which could be an example of an unbalanced force? A plate sitting on a dining room table. B, a ball at the top of a hill that is not moving. C, a car parked on the side of the road. D, a baseball moving through the air after it was thrown to home plate. There are vocabulary words on your answer sheet. Use the space around them to jot down notes and drawings to help you remember their meanings from the reading. Now you're going to go to this website and watch the video and answer the next 3 questions. I have this website up, so we're going to go to it and play it.
Balanced forces. The famous English scientist Sir Isaac Newton, who lived between the 17th and 18th century, devised 3 laws of motion. The first law states that if all the forces acting on an object are balanced, there will be no acceleration, meaning either constant velocity or the object remaining stationary. But what do we mean by balanced forces? Let's look at the example of a horse. The first force we will consider is the force of gravity. This acts towards the centre of the Earth. The size of the force of gravity is the horse's weight. An arrow is drawn downwards from the horse towards the centre of the Earth. If this were the only force acting on the horse, it would sink into the ground. As this is not the case, there must be a force opposing the force of gravity. An arrow is drawn in the opposite direction, but equal in size. This force is called the reaction force. As the reaction force is the same size, but acts in the opposite direction to the horse's weight, these two forces are a balanced pair of forces. There are other forces acting on the horse. The horse is moving forward, and therefore there must be a driving force from the horse's legs. The driving force, though, is opposed by the forces trying to slow the horse down, and if the horse is travelling at a constant velocity, the force of friction and air resistance are equal in size but opposite in direction to the driving force. The driving force is now balanced by friction and air resistance, a balanced pair of forces, and the horse now travels at a constant velocity. If though the horse accelerates, the driving force must be greater than friction and air resistance. The driving force is now no longer balanced by friction and air resistance. These forces are now unbalanced. So in summary, when the forces are balanced on an object, the object will either remain stationary or travel at a constant velocity. When the forces are unbalanced, the object will either accelerate, meaning an increase in velocity, or decelerate, meaning a decreasing velocity.
Okay, so that is the video that we're supposed to watch.
Balanced forces.
And now you're going to answer the question. What is one example from the video of a balanced force? Be specific. What is an example of in the video of an unbalanced force? Be specific. Summarize in 3 to 5 sentences what the video is about. Have one person sit in a chair without moving. Fill out the data table on your answer document, which would be right below. Okay? Have one person sit in the chair, then 2 people will push with an equal amount of force in opposite directions on the chair. Fill out the table on your answer document. What happens then? Have one person sit in the chair, and then 2 people will push with an unequal amount of force in the opposite directions on the chair. Fill out what happens on your table here. Okay? Now, going on, we're going to watch another video, and then you're going to take and listen to the questions. When you get to this particular website, you're going to click on friction. Once you've clicked on friction, then you will go through and you will take and apply your forces in equal and opposite reactions. You will go through and you will do this for each one of these things. You will choose which newtons you want to do and take a screenshot and insert it here. Turn on all the check boxes in the upper right corner. The box sitting is still considered a balanced force. All forces, gravity and the force on the ground pushing up, are equal. Change the applied force to 500 newtons. The box will begin accelerating. This is an unbalanced force because the applied force of the man pushing it is greater than the force at friction. Play around for no more than 5 minutes and experiment with different objects and scenarios. Using the observations from the lab that you just did, describe the differences between a balanced force and an unbalanced force. Make sure for this one right here that you take a screenshot of your change of 500 newtons. We're going to skip this particular slide. In this event, I'm going to delete it. So right here, you're going to take and you're going to match your balanced forces and your unbalanced forces. Balanced forces, you would take and you would move them over to where they are. So a parachute is falling to the ground would be an unbalanced force. So you would drag and drop there, so on and so forth. This is a show what you know slide. Answer this question on the document list. List 2 examples of a balanced force and 2 examples of an unbalanced force. You can do this in a text box instead right here. Draw a picture on your lab sheet that demonstrates your knowledge of balanced and unbalanced forces. So draw an object that is balanced and then draw an object that is unbalanced. Take a picture and insert the picture here on the right. Then you're going to answer these questions here. An object at rest has equal forces acting on it. This can be described as a blank force: gravity force, unbalanced force, balanced force, or physical force. An object that is accelerating can be described as a blank force: a gravity force, unbalanced force, balanced force, or a physical force. Which is the best example of an unbalanced force? A book resting on a shelf, a train accelerating from the station, a chair sitting motionless, or a car driving at a constant speed. Use the vocabulary words from the Read It slide and answer these questions. There are a few things we can observe about objects around us. A blank is a push or a pull of an object. And blank is applied to an object 2 forces that aren't equal in size and acting in opposite directions, then a change in motion can occur. If the object doesn't move or continues to move at a constant speed in the same direction, then a blank, which is 2 forces equal in size and acting in opposite directions, must have been applied. All of these types of forces can change the blank of an object, rate of change of the position in some time, or the blank of an object, the straight path of an object that moves along. So you're going to go back to your Read It here, which is at the top, and you're going to look at your vocabulary words and use these to fill in that slide on slide 11. Slide 12. On slide 12, tell me what is the differences between balanced and unbalanced forces. Why is rolling a ball down a hill considered an unbalanced force? Describe how the bowling pin will react to the unbalanced force of the bowling ball. And then right here, you can take and write your answers in for slide 11. And that is all for today.